In this video, we're going to use truth tables to prove a proposition. Namely, we're going to prove that P and Q implies Q or P. That's this proposition written at the top. And on the right hand side of the page, we have sort of three elementary truth tables. The first one is the AND truth table, then we have the OR, and then finally at the bottom we have implies. These are elementary truth tables, and or implies. These three you'll just have to know in order to do any truth table proofs. Okay, so let's look at the question. We have to prove P and Q implies Q or P. So we're going to use truth tables. We're going to draw a truth table. The sort of input propositions are just P and Q. So we're going to have P and Q on the left hand side of our truth table. And we have to sort of consider the different values that P and Q can take. Well, they can both be false, FF. We can have P false and Q true, so that's FT. We have P true and Q false, so true, false, and both true. Okay. And these are all the different pairs we can have. In the fact, there's 4 rows to this truth table. In this truth table, we have 2 inputs, the P and Q. So the number of rows is 2 to the power of the number of inputs. In this case, we have 2 inputs, so 2 squared is equal to 4 rows. If we had 3 inputs, PQR would need 8 rows because 2 cubed is 8. Okay, so this is how we start our truth table with our PQ. And in this case, we want 4 rows. Now we need to consider our proposition. And we're going to break it into pieces. So the first piece is the P and Q. So what we're going to do is we're going to use our elementary truth tables on the right, in this case the AND truth table, and we're going to fill in the column for P and Q. Now AND is the operator that takes a value true only when both of its inputs are true. So the AND operator is true only when both inputs are true. So we can fill in this column, P and Q, using the elementary truth tables. We're going to do the same for Q or P, because that's another thing that we is useful in our original statement. Now the OR operator, again, we're going to look at the elementary truth tables. So OR is true in every case apart from the case where both inputs are false. So if both inputs are false, remember the inputs here are Q and P. So if they're both false, then Q or P is also false. If at least one of them is true, then Q or P is also true. So we can fill in our column for Q or P like that. Now we're almost done. We just have to look at the final step, which is really the whole statement. P and Q implies Q or P. So we're going to use the 2 columns that we've already created, the P and Q and the Q or P column, and we're going to combine them with the sort of elementary implies truth table. Well, the elementary implies truth table at the bottom, if you look at it, it returns true in all cases apart from if the left hand value is true and the right hand value is false. So implies returns true if we have. So let's look at the truth table we're creating. This is P and Q implies Q or P. So the left hand side is P and Q. The right hand side of the implied sign is Q or P. So the first case is F. Our 2 inputs are FF. Well, for implies, FF returns T. So FF returns T. For implies FT, so here we look at FT, and in our circle on the other side, on the right hand side, FT returns T as well. Same again, FT implies T, and then in a different color we can look at the last row, TT, TT here leads to T. And just finally, because I skipped it the first time, the FF, just to show where that came from, FF here, I've searched in green, so FF returns T. So that's why we have hopefully you can sort of match that up, see how we've just used the elementary truth tables on the right hand side of the screen. Okay, and now if you look at our main truth table, notice that all our final column is just T's, so everything is true. And that's it. If we end up with a truth table where everything is true at the end, then we've proved. We've completed our proof. So therefore, our proposition is always true. So I'm done. And that proposition was P and Q implies Q or P.